what will happen, this doesn't matter how big it looks, doesn't matter how big this barbell system looks, or what is the distance, it is one barbell system. It's representing same time, same x, same y, same reality. Therefore, if we collapse it here by imposing a reality or imposing a place at another place, it will collapse because it cannot represent two places at the same time. It represents, or two reality at the same time. It represents the same reality and same time and same place. Therefore, when we want to impose another reality to that, or we want to impose a reality, measurement is reality. Basically, it's information that we get from this system. This system will collapse immediately, and the matter in it, the matter that is addressing, ends up completely, it can end up anywhere, because we just collapsed it.
So entanglement ends between our particle and all other particles which are in
Yes. Entanglement is basically when we have that balloon with the hand, like we have, actually we should buy this balloon because we can use it a lot. With one hand, like pushing it, and we look like we have two balloons. But this is the same time, same place, and same reality. Therefore, when we impose to it, it ends up in one of the collapsed fabrikas.
We take out our particle from that subspace when we measure.
It moves to a normal space.
So we remove it from this subspace.
We know and it ends up in one fabrika rather than like the handshake will collapse. And let's say four of us we handshake, and then we have one ball, like it is in there in the whole, like it's moving for itself in the whole system, and then when we lose our handshake, it will end up somewhere, and you cannot predict even where, because there is no information circulating here. You know, when we are talking about information in physics, that is actually the catastrophe currently they have with the black hole, near black hole, basically radiations, because the information gets lost. But in this system, there is no information yet. This is representing a reality that when you collapse the system, it will have a number. You know, so that is the difference. In uncertainty principle, they are saying that particle, you cannot know the place of the particle. It's uncertain. And if you measure it, basically it will end up, they are talking about places. In this system, we are talking exactly about one place with the different shape and different system, the different shape and style, and the particle is still there. It looks like a wave
everywhere,
and it's everywhere, but it's not. And that's how also we can solve the problem between gravity, like for sure we changed already the gravity theory of the general relativity completely, but still we can solve the problem of the gravity as well, because this is just one particle and in one place. The place itself waved, the place itself changed. Okay, so I think the image is clear. And the equations all will work. Like the equations of quantum physics will work still. Like because
after you measure, then starts quantum mechanics. After
measurement, basically but this basically will fix the quantum physics and GR at the same time. The problems that they have. You know, GR has a very big issue with black holes because of the formula. It caused infinity in the formula of GR, which doesn't make sense. In this, we don't need the infinity. Okay, so questions?
So matter is somehow embedded in subsystem until we measure it, we remove it.
Yes.
from this Barpa subsystem.
Yes, but this Barba system, when it creates, it has a wave, it has a shape, it has everything that basically looks like a liquid, and it represents same time. It is very important also in the calculations, and until we collapse it.
So it's like taking drop out of that liquid. It's like a subsystem. If I take drop,
Yes.
it's lost connection. This
Yes.
material lost connection with the.
But that whole liquid will also collapse.
But it will stay for itself.
Yes,
But that particle is in my hand now.
yes, exactly,
And this is so
Yeah.
connection is lost.
yes.
And
Yes.
then it is like one. You cannot say the drop is here. No, it goes everywhere.
Yeah.
It's
It
everywhere.
is not going everywhere. In this system, it is still there.
Yeah, but
particle is still
inside
there.
subspace.
But we made, it is, that's why actually I think we should give it completely new name. Because when we say subspace, the space, it has, you can, for example, give it the GPS coordinates,
Yeah.
right?
Subspace means space.
Big,
and
which is not the
this
case.
is here.
This is as big
Space.
as one Fabrika. It works like one Fabrika.
One power.
Maybe like I don't know, a very large number of Fabrikas handshaken and created this, but they work as one.
One.
Yes,
Many fabricas.
they are representing same space at the
merge
same
into one
time.
fabric.
Exactly.
So size of subsystem doesn't matter.
No, it can be as big as universe, and it can be as Planck size. That is the case, and that's how we can actually address a lot of problems that create. Quantum physics. What happened in quantum physics? They addressed the whole tests and experiments with equations, and the equations turned out right because they could calculate. Therefore, the predictions are right. Now, in this system, we are ending up with the same predictions mathematically, but we can address the problems that quantum physics doesn't have any answer with. Because rather than setting the particle or basically movement in the framework, we start waving the framework itself.
XYZ.
Exactly. That is changing all the time. That is collapsing and attaching all the time. That is the framework itself which is changing and collapsing. And that's how we can address all of the special relativity, general relativity, basically paradoxes, and incompatibilities with quantum physics, and end up at the same time with the same result, same calculations, as they predicted, for sure, except GR. I think in GR we are gonna end up with very better calculations, especially about galaxies. Because in GR, it is a curvature of space and time. Therefore, curvature of the space and time, they can get cancelled by each other. In this theory, it doesn't get cancelled. It is not a productive, it will be a productive wave. It's not gonna be like a destructive wave. In general relativity, it is destructive wave.
Here you say because number of fabricas is never
Getting lost, yes.
never negative.
Yes. It is getting subtracted from, like, we subtract the space. In gravity, it is subtraction of the fabricas. It's always subtracting. But the thing is, if you have two items, let's say we have a number of sandwiches here, I'm gonna actually say that, and you start eating from there, I start eating from there, we will finish sooner. But in general relativity, the difference of the understanding, because it is curvature.
It can be negative and positive.
Yes, you are positive, we are going to cancel each other. We are going to cancel each other if we are against each other. And this is not happening exactly in our situation because we don't have any huge mass near Earth to test it unless we send the clock in the Earth, like under the ground. And then we can understand if the problem of the GR formula is gonna be exist like there as well. But in this theory, what we are gonna do, we are gonna actually set the gravity as subtracting the space, time, and reality, and like the Fabrika quantas. And then this will address a lot of issues that is created currently with GR theory of gravity.
Yeah, one have to think what can one prepare, compare computation here with computations there.
Yes, that calculations will end up correct in 99.9%, like Newton law of gravity. It was correct in 99% of the situations. That 1% talks about how reality works. That 1% that cannot address. And the 1% that cannot address, I'm gonna still write this because it's important. Fabrika.
What affects the number of Fabrikas?
Matter first. Matter will subtract Fabrikas all the time.
When matter meets with Fabrika, it will eat it up, kind of?
It will eat up we can say eat up, or it will reduce the number of Fabrikas. That's why actually we feel the gravity. Because the matter under us, yes, is always destroying these balloons. And we are actually always falling. Because the balloons under us, they are falling, and from the whole universes they are coming to us still. Like, I cannot say exactly because they are representation of space and time. You shouldn't say balloon, but I'm saying it to just matter of explanation. This is really a bad explanation, balloon. But anyway.
How acceleration is connected to the destruction of balloons?
No, why? Okay, that is equality principle in GR. Yeah, equality principle also works here. Let's say I'm in a lift. Okay? On the earth. I don't have any window here, correct? Nothing.
No window, no.
No window, nothing. I am in a rocket going with G, and I have no window. You cannot, GR says this, you cannot understand or measure that. Are you in this rocket, in the space, with G acceleration, or you are here, static on Earth,
static on the planet which has G?
Okay. How we are actually solving this in Fabrika? Pretty easy. How many Fabrikas I pass with this? Like, because Earth is eating Fabrikas all the time. And the Fabrikas, they have action on the mass. This is me. All the time. So basically, they are passing me all the time. They are passing me. The Fabrikas from the universe, like going through me all the time. And I'm kind of moving through Fabrika. I'm moving through a space all the time. In this and in this. With the same acceleration. You understand what's happening? Let's say I have 1 million balloons under me and I'm standing on these balloons, right? And these balloons are always destroying, okay? I'm falling, right? I'm falling. As I said, it's a really bad example, it's just a matter of explanation.
Yeah.
I'm falling all the time. Now let's say the other way around. Like these balloons are creating. Or this balloon, like I'm actually moving through like a large number of balloons every minute, the same amount, same amount. So that is the definition of gravity in this case, and basically that is why time dilation also happens. In both cases, same number. Why? Because when I'm passing Fabrikas, when I'm passing it all the time, this time factor of the Fabrika will start to affect me differently.
Giving you delta t or taking from you delta t?
No, it is, I'm not passing it that much. Like, I'm not gonna pass the time that much because I'm passing the Fabrikas in space more, and therefore their time dimension has less effect on me. Again, Lorentz transformation, exactly Lorentz transformation, but in small frameworks. Like instead of one big framework, which is always happens in special relativity and general relativity, this small framework, each one respects kind of, we talk about Lorentz transformation later, each one also has the same calculation in Lorentz transformation. So basically, we have x1, t1, x2, t2, x3, x3.
Small coordinate system.
Yes, a small framework, as small as Planck basically size. It's small framework, and why we are quantizing the framework? It is extremely important because suddenly in the middle, one framework can disappear or doesn't have less effect on us. If I'm passing it fast, therefore Lorentz transformation will work also in these frameworks, but for a different reason. You know, not the reason that this happened like the other general relativity as a curvature of this, but losing this space or passing it without getting the effect of it.
We are moving from one Fabrika to another?
To another, yes, we are moving, and then the faster that I move, the more Fabrikas I pass, the Lorentz transformation will work in each one exactly against time of me.
To slow down.
Yes, I will, and the more like I speed up, the basically the less effect I will get from the time.
To slow down our time.
Yes. That's how the clock also is slowing down, but it's still quantized. It is not addressed in general relativity at all. In general relativity, the time is not quantized as far as I understood the general relativity.
No, time
is not quantized.
Continuous, yeah, continuous.
But in quantum physics, time is quantized. All of the quantum physics proven experiments can be addressed by this as well. Because rather than having like Lorentz transformation in one framework, we have like a lot of Lorentz transformations in basically for each of these frameworks, and we can actually calculate whatever can be predicted by GR and quantum physics without losing the compatibility and without two big problems. Remember, we are addressing 2 or 3 big problems here with this theory. The first problem that we are addressing here is black hole catastrophe of GR. In general relativity, Albert Einstein could not address what is happening in black hole because it is more than the speed of light. The gravity there is like more than the speed of light. Therefore, they will end up with infinity in the calculations. That is a singularity, and that is creating a big problem in physics now. This is the first thing that we are addressing to solve in GR. At the same time, because when it's quantized, the calculations will have a finite answer, not infinite. The exact same thing that ultraviolet catastrophe made Planck discover the Planck distance and Planck space. Ultraviolet catastrophe is a very interesting fact. This is exactly the same thing that we are going to actually address in black holes. And in quantum physics, what we are going to address, which is a big dilemma now, is a double slit experiment with quantum erasure. This system will totally address it because it's the same time and space and reality. And therefore, because it is same, when you collapse the system, it seems it affected the past. It seems the electron or the photon knew what is going to happen. No, that's the same system. That's the same BARPA, and it's the same system. So the calculations will end up right. We can mathematically even prove it, like this was the same system, therefore, and we end up with the same predictions of quantum physics in whole, same predictions as GR, like almost. And the predictions that we are going to do with this will be more accurate than GR. Okay, now I'm gonna actually write down again because it's very important. Fabrika. Fabrika is the definition of existence. Why? Because it has dimension of R, reality. This is the most dimension, the most important dimension in Fabrika that we are defining. It has definition of time. It defines time. It defines R. Be careful. It is very important. It's not getting affected like particles. Particles are getting affected by time.
So Fabrika has it by itself attached
It is time.
coordinate system of X, R.
It represents exactly. It represents the time, represents the reality, represents the X and Y and Z.
Like a small system, moving system.
We should say a smallest framework. At the same time, it can be as big as universe. Because there is no limit on handshaking the Fabrikas. It can be as big. Maybe the whole universe also is a system. We can think even about that to realize what happened in the Big Bang. And then, Fabrika, subtraction of Fabrika means gravity. So when we are removing, like Fabrikas are getting disappeared, the gravity, this is what is gravity.
Pulling effect.
Yes. And this theory predicts anti-gravity. This is one of the things that we are predicting, called protraction. Protraction of Fabrikas.
And what creates Fabrikas? What effect?
Fabrika, curious Fabrika.
Fabrika.
Yes, with a rate that we are gonna actually find. So they have a rate, and this rate is one of the static, basically one of the values that we can find after calculation.
There is a constant of that model.
It's a constant of this model.
C is
Yeah.
constant for.
Yes, this is a constant of this model, exactly. We are gonna actually find a new constant based on the data that we received from, we can find on internet, on NASA or on other websites about expansion of universe and their observations. We can find a new constant. Therefore, we have subtraction of Fabrika, means gravity. We have protraction of Fabrikas, means dark energy. We have, this is extremely important, we have BARPA system, which defines what happens in quantum mechanics between waves and particles by defining a framework, a merged framework between a lot of Fabrikas, create a bigger framework. That's how waves, they can actually affect each other. That's how reality even can affect each other.
So this BARPA is needed for non-locality problem, yeah?
Yes, actually non-locality, we define it in totally, it is similar to non-locality somehow, but we define it in a totally different system. We define it as basically definition of existence. And then it can create a system that can actually wave, framework itself with wave, not the particle. And that's how we can define what is happening in superposition, what is happening even in quantum computing, because in quantum computing what is happening, you will end up with a reality at the end of the calculation, which is matched with what you are expecting, kind of. It is like predicting the future. But when you define that as a BARPA system, you will understand how quantum computer can predict the future by superposition. because it is the same reality, same time, affecting even the past, somehow, in the eyes of the observer, out of that Barpa system. It affected the past, but it is same, representing same time and same place and same reality.
It is like a system where God lives, who knows everything and
Yes.
everything and the future and the past. And
Future can, it seems, can actually change the past. Okay, so basically, we will have similar calculations as quantum mechanics, but the way that we are doing the equations will be more by changing the framework rather than changing the basically predicting or talking about the particle.
yeah, so formulas one have to think how to. So let's say subtraction is like G.
Yeah.
One have to.
We have a rate of subtraction. The more mass that we have, the more subtractions we have. And basically what will happen is very simple. We are gonna actually define G with a new constant, like rate of subtracting Fabrikas. And this will again address a lot of things in quantum physics that are incompatible, totally incompatible with the current GR theory. So basically gravity is quantized, but in a very specific way. And yeah, so basically we address dark energy. We address dark matter for sure, because with new calculations that we are gonna have, the dark matter doesn't need it exactly. It is still, it is subtraction with a different equation. And therefore, we can actually, as I mentioned, because in GR, curvature can cancel each other. In this, they are not canceling each other. When we have like a huge, like a galaxy type of mass, they are not canceling each other. The whole galaxy is eating up totally, like with collaboration with each other, like a productive kind of wave, not destructive wave. And the only thing to prove this theory is right is exactly the new equations that we are going to create for defining the gravity in the presence of more than two objects. And we don't consider it, because when we have just two objects, like it's us and this is Earth, the calculation always works with GR. It works perfectly. Mm-hmm. But what if we have three objects and we have millions or billions? The calculations of GR will have a problem here and has a problem, show the problem. It is not me that's saying. They invented dark matter concept to say, okay, that's why galaxies are heavy and look heavier than what they are, like what they are. But when we have like a lot of planets and stars, what will happen? In GR, they're canceling each other somehow in the large number of calculations. In QTT, they are helping each other to have more and more gravity. Yes, because that is a difference, small difference, but as I said, in that number it will be huge when we are talking about subtraction of Fabrikas and we are talking about the general relativity's gravity.
Yeah.
So 70%, what they say is this, is 70% of the mass of galaxies are missing. Therefore, they called it dark matter. Because they could not address the gravity, especially on outer layer.
They could not measure that mass.
Based on GR.
Based on telescopes and...
GR.
Yeah. Observe. They cannot observe the rest of the mass.
And what is that mass? Remember, this mystery mass, dark matter,
missing,
they understand it because there is a gravity that is not accounted for. Correct?
And not visible through telescopes.
Not visible through anything. They could not even find any sign except gravity for this. So therefore we have two options. Either general relativity needs a kind of correction, or there's a mass that we cannot see, and it's 70% of the galaxy. So it is basically the representation of the missing calculation in the gravity of GR. You understand what I'm talking about? Like, so that's why they say there's mass, and 70%. And we are not talking about 1 or 2 or 3.
The way galaxy rotates, there should be more mass inside.
70% more. But with the calculation of basically QTT, we are going to show, because as I said, it is accumulative. It is not cancelling each other out. We can actually have the same predictions and GR in just 2 or 3 or I don't know, like for example, Sun and Earth type of mass, and then we can actually calculate the bigger numbers as well.
But in ZQTT, that larger mass will be accounted by protraction or by what?
No. Protraction happening in the whole universe.
Yeah.
Protraction, because Fabrikas are everywhere. Fabrikas actually are elements that they created their reality in universe and time. They created that. The whole existence is created by Fabrikas. Therefore, when they are expanding, their reality and time and space is expanding. That is the protraction of Fabrikas.
Because of that, size of space-time increases, yeah?
And why it is accelerated 4 billion years ago suddenly? Why? Because gravity, the subtraction of Fabrikas, could not eat up
enough
as much as it was protracting. So suddenly it's bursting or expanding or whatever.
Like cancer cells.
Yeah, it was like, it is like this. This is a mystery. What happened 4 billion years ago? I will tell you what happened. They don't know the answer, and they say we don't know. Okay, here is the answer. Matter, we have an amount. It's not changing, right? Not that much. It was eating up, subtracting the space and time and Fabrikas. And suddenly, certain point, because Fabrikas are creating Fabrikas, the number of Fabrikas started to rise up before matter can actually eat it up enough. You know what I mean? Till here, matter could eat up Fabrikas to not accelerate that fast. But after a while it became, because they are accelerating in every dimension. And matter is static, matter is not changing. We are not seeing new galaxies are creating out of nowhere. It is from the gas or existing hydrogen or whatever. It's not changing, it's like atoms are, or particles are not creating.
How is matter created? How is matter created?
We can actually, okay, this is basically a question that can answer that everything started, because that is the question that they don't have the answer. I think they know what happened after a few nanoseconds or something, but not before that. What we can say is that Fabrikas are creating Fabrikas. Then basically the first Fabrika started to recreate the first Fabrika.
Was it before mass creation or after?
Before mass creation.
Okay.
Certain effects happened, and before it can actually create other Fabrikas, it created, a large number of other elements and particles. But when it reached to a certain point, we can actually calculate that as well. It is just a theory. It is, I should think about this. To be honest, I did not think about this that much, but we can actually
Fabrika creates mass, not Fabrika, but mass.
Fabrika's interaction may created mass. So they could not basically handle each other properly. They clashed in a wrong way, or we can say
Defect, man.
yes, and that created mass until certain amount of time. And after that, they had enough space or enough, basically, not a space.
Some friction maybe.
Yes, to expand it. But this is just an idea. I'm not sure about it that much.
Very
Yes, we can actually think, but with this system, it is actually easier to think. Because when you think, the Fabrika is basically the size of a plank, minimum measurable distance, you can actually think about Big Bang way easier as well. Because the problem is what happened in the start and how that happened.
Yeah, to be honest, now I'm not professional of this creation and then inflation theory, and now I think I have need to listen at least at popular level.
Yes, sure.
How it's explained matter, first creation is the inflation.
But in
model.
my mind, it's better not to think about it now, because this is not addressed by general relativity or quantum physics at all.
No.
Why we should address about it now?
It is
it is not, in my mind,
Cosmology
this model,
yeah,
yes,
cosmology.
it's way easier to address it. But when we have time and energy to think more about this, okay? Because this can address a lot of problems, a lot of challenges like dark energy and dark matter. Therefore, addressing Big Bang with these can be easier.
Yeah. You know, now I will do that at home, and maybe if we have time, we can also listen here.
Sure.
There is a version of quantum mechanics,
Mm-hmm.
not orthodox, and it's a Bohm's Bohm. You know that name?
I
Bohm's-
heard.
Yeah, he is exactly the guy who was saying, I don't believe in that. I want to explain what happens before measurement. We can listen. Bohm. He is a famous guy. Bohm.
Yes.
Bohm version of this is different from Copenhagen version.
Okay.
Actually, I've seen even books.